Okay, find individual force values. So we did something like this earlier. Um, if our net force is 0, that means if I have 200 going down, B would be 200 going up. Just like 50 going to the right, since my net force is 0, A would be 50 going to the left. It'd be all balanced, right? Now if my net force is not 0, let's say it's 900, and it's going up. If I have 200 going down, to get 900 going up, I would have to take 200 plus 900. I'd have to have 1100 for C, because 1100 minus 200 would equal 900. So I got 60 newtons left as my net force. So that means 80 minus 60 would be 20. So D would be 20 newtons. And then I'm going to be balanced in the vertical. So if I have 300 here, I'd have 300 going down. So E would be 300. If my net force is 30 newtons to the right, and I'm going 20 this way, I need 30 plus 20, so G is 50. And then F and H would be equal, whatever you want them to be. They could each be 10, they could each be 20, doesn't matter. As long as they're equal, then we're balanced. Do this now.
All right, so here we got friction, 15 newtons back. We don't know normal gravity or applied force. We know our mass is 6, acceleration 0, and we don't know net force. As soon as I know mass and acceleration, I can solve for a net force. So we're going to do that first. And so force net equals 6 times 0, right? Mass times acceleration, which is 0. So my net force is 0, which means all my forces are balanced. So if friction is 15, my applied force is 15. Find my force of gravity. It's mass times 9.8. So this is going to be 6 times 9.8. And I get 58.8 newtons. And since we're all balanced, my normal force is also 58.8 newtons.
Do this now.
All right, so we don't know any forces. We know coefficient of friction is 0.2, mass is 10, acceleration is 0. Right away we can find net force. Force net equals mass times acceleration, so 10 times 0, which is 0. Net force is 0, which means all our forces are balanced. I don't know any forces to balance yet, but I can find the force of gravity because it's mass times 9.8. If my mass is 10, 10 times 9.8 is 98 newtons. So if this is 98 newtons, normal force is 98 newtons. Now I can find the force of friction. Friction is mu times normal force, so force of friction is equal to mu times my normal force, 98. So if I take 98 times 0.2, I get 19.6 newtons. And since I have a net force of 0, 19.6 friction would mean I have to have an applied force also of 19.6.
Do this now.
All right, so here we got, again, don't know any forces. We know our mu, we know mass, we know acceleration. So we can find net force. Again, net force equals mass times acceleration, so 10 times 2, which is 20. So now our net force is 20. So that means we're going to be 20 one way or the other. Now, since we're on a flat surface, if we can find this, we can find that, right? So let's look at Fg is mass times 9.8. So it's not 10, it's 5. I'm sorry. This is 5 times 9.8. 5 times 9.8 is 49 newtons, which means my normal force is 49 newtons. Once I know my normal force, I can find friction, because friction is mu times normal force. My mu is 0.1, my normal force is 49. My force of friction is 4.9. Now my net force is 20. Since my acceleration is going right, my net force is going 20 to the right, okay? So essentially it turns into this force, which I'm going to call x, minus 4.9 equals 20. If I add 4.9, x is equal to 24.9. So my applied force is 24.9. So a little extra step here. We kind of did that on the first slide, but here it is in action.
Do this now.
All right. Applied force 25, mass 4, acceleration 2.5 to the right, net force unknown, and then the other forces and mu unknown. But let's start with net force again. Force net equals ma 4 times 2.5, which turns out to be 10 newtons. So my net force is 10 newtons. I can find the force of gravity. That's equal to m times 9.8. My mass is 4, so 4 times 9.8, 39.2 newtons, which means my normal force is 39.2 newtons. Now to solve for friction, I can go one of two ways. I'm going to use this way first. My applied force is 25, my net force is 10 newtons to the right, so that means 25 minus friction, which I'm going to say is x, is equal to 10, right? Subtract 25, negative x, negative 15, make them both positive, x is 15, so my frictional force is 15 newtons, which means the difference between those should be 10, which it is. And then I want to find mu, so I want to solve for mu. Frictional force is equal to mu times normal force. Frictional force is 15, mu is unknown, normal force 39.2, so I divide both sides by 39.2, and there's mu, which is 0.4. So a little more to this when you start having a net force and you got to start thinking about how to find these numbers. But again, not impossible to do. You just got to concentrate and remember your 3 equations.